my name is Shirin, and today I'm going to talk about mathematical modeling in biology. And I'm going to talk about how we can build a simple model to get an insight in biology. And specifically, I'm going to talk about saturation. So as an example for saturation, let's think about a glass of water. And then when we add water when the glass is not full, so we can add more water to the glass. But when the glass is saturated by the water, it's no place for the extra water. And this is we call saturation. And now I'm going to talk about the saturation in this phenomena in biology. So let's think about the enzymes. The enzymes which can take the substrates, the foods, and so that one can take this substrate, take the second molecule of the substrate, and the last one take that one, and then all of them are fully occupied and catalyze these substrates and gives us the product. But if we add more substrates, since there is no available enzymes to take these extra substrates, so the enzyme is saturated by these substrates, and they actually don't have any effect on the reaction rate. And let me explain this by drawing it. So on the x-axis we have the concentration of the substrate, and we show it by this. And so you can just think about it as a food. And then we have the reaction rate. So reaction rate is a changing of the concentration of the substrate by changing in time. And we can actually describe it with this plot, and here we have the Vmax. But what this plot shows us is that when we are when we are in this area, let's assume we have 3 substrates, and that means that when we add the amount of the substrate, the reaction rate increases until we get to this point, and then these 3 actually are exactly same as these 3. But when we add more substrates, like here, they don't really affect the reaction rate, and the reaction rate reaches to the Vmax, the maximum value of the reaction, and they don't affect the reaction rate. And then let's see how we can describe it through a very simple mathematical model. So we show change in the concentration of S by changing time, and we use a Michaelis-Menten kinetics. So a Vmax times the concentrations of the substrate divided by Km plus concentrations of the substrate. And delta is actually a change in the concentration of the substrate. And if you plot this expression, you get exactly this plot. And Km is actually, if I want to show Km, Km is the amount of the substrate at which we get the half of the rate. So and here we show that with a very simple mathematical model, we can describe this phenomena situation. And then you can even make it even more complicated by adding complexity to the system and build a model for a network of the reactions.